Mathematics, majoring Mathematics, Faculty Mathematics and Natural Science, Padang State University. Okay, I will presentation a topic about matrix operation. Okay, before we go into the matrix operation, I will explain what is the matrix. A matrix is a rectangular array of numbers written between a rectangular bracket. An important attribute of matrix is size or dimension, the number of columns, and the number of rows. A matrix with m rows and n columns is called m times n matrix. Example of matrix: the 2 times 2 matrix. The 2 times 2 matrix have second rows and second column. This is 2 times 2 matrix, and the 3 times 3 matrix have third column and third rows. Okay, after we know about matrix, we can go into matrix operation. There are 4 matrix operations. First, matrix addition and matrix subtraction, scalar matrix multiplication, and matrix multiplication. Matrix addition. 2 matrices can be added together if they have some rows and some columns. The result is another matrix of the same size, obtained by adding by corresponding element of 2 matrices. Properties of matrix addition. First, commutative. 2, associative. 3, adding by zero matrix, and 4, transpose of sum. Commutative. If A plus B is equal to B plus A. And associative. Bracket A plus B close bracket plus C is equal to A plus bracket B plus C close bracket. We are therefore write both A plus B plus C. Addition by zero matrix. We therefore write addition with zero matrix. Adding the zero matrix is no effect. Example, A plus zero matrix is equal to zero matrix plus A matrix is A matrix. Addition with zero matrix. And then transpose of sum. Addition with zero matrix. A plus 0 is equal to 0 plus A is equal to A. Adding by zero matrix has no effect. And then transpose of sum. Bracket A plus B close bracket transpose is equal to A transpose plus B transpose. The transpose of sum of 2 matrices is the sum of their transpose. Example of matrix addition. We adding the corresponding element of the 2 matrices. Matrix 1, 3, 2, 6 plus matrix 0, 1, 3, 2 is equal to 1 plus 0, 3 plus 1, 2 plus 3, 6 plus 2 is equal to 1, 0, 5, and 8. Okay, matrix subtraction. Subtraction of matrix is possible by subtracting the element of another matrix if they have some order. Properties of subtraction of matrix. It's non-commutative operation. If we reserve the order of the matrix, both of them, with the same order or dimension, the result will differ. A minus B is not equal to B minus A. The negative of matrix A is written as bracket negative A close bracket, such that if the addition of matrix with the negative matrix will always produce a null matrix. A plus negative A is equal to 0. Condition for subtraction of matrix. Two matrices should be of same order. Number of rows is equal to number of columns. Add the corresponding element of the matrix. The example of matrix subtraction. Let A matrix 5, 4, 3, 7, 8, 9, 3, 12, negative 5, and B matrix 2, 3, 4, 4, negative 5, 6, negative 5, 12, 8. Find A minus B. We can subtracting the element. 5 minus 2 is equal to 3. 5 minus 1 is equal to 5 minus 3 is equal to 1. 3 minus 4 is equal to negative 1. 7 minus 4 is equal to 3. 4, 8, negative 8 minus negative 5 is equal to 13. 9 minus 6 is equal to 3. 3 minus 0 is equal to 3. 12 is 12 minus 7 is equal to 5. Negative 5 minus 8 is equal to negative 3. Scalar matrix multiplication. Scalar matrix multiplication is multiplying every element of matrix by scalar. Example of scalar matrix multiplication. Let A is matrix 1, 6, 9, 3, 6, 0 and find negative 2 times A. Answer: negative 2 is scalar and multiplying negative 2 to every element of matrix A. Negative 2 times 1 is negative 2. Negative 2 times 6 is negative 12. Negative 2 times 9 is negative 18. Negative 2 times 3 is negative 6. Negative 2 times 6 is negative 12. Negative 2 times 0 is 0. Matrix multiplication. We shall define the product A times B of two matrices A and B. This is defined for of all size with one restriction. The number of columns of A must equal to the number of rows of B. If A is an M times N matrix and B is N times P matrix, then their product AB is an M times P matrix. Row vector times column vector. Let A, B, C matrix and B, P, Q, R matrix. Then the definition of A times B is A times B is equal to A times P plus B times Q plus C times R matrix. Example: 2, 3, 5 matrix times 3, 4, 7 matrix is equal to 2 times 3 plus 3 times 4 plus 5 times 7 matrix is equal to 53 matrix. Square matrix times column vector. Let A, B, C, D, E, F, G, H, I and B, P, Q, R. Then the definition of A times B is A times B, A times P plus B times Q plus C times R, D times P plus E times Q plus F times R, G plus times P plus H times Q plus I times R. And the example: matrix 2, 3, negative 1, 0, 1, 0, negative 4, 3, negative 1 times matrix 1, 3, 5 is equal to, we multiply the rows and the column. 2 times 1 plus 3 times 3 plus negative 1 times 5 is equal to 6, and we multiply 0 times 1, 1 times 3, 0 times 5 is equal to 3. Negative 4 times 1 plus 3 times 3 plus negative 1 times 5 is equal to 0. Square matrix times square matrix. From the PowerPoint, we can see first row we multiplied with first column, and first row we multiplied with second column. First row we multiplied with third column, and second row we multiplied with first column. Second row we multiplied with second column, and second row we multiplied with third column. And then third row we multiplied with first column. Third row we multiplied with second column, and third row we multiplied with third column. And the result is negative 1, 2, 11, negative 1, negative 5, 18, negative 18, negative 2 matrix. That's my presentation about matrix operation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.